find the inverse of the graph. On the left here, there's the graph. I call it f of x, just to give it a name. And here are some very important points on this graph f of x. There's -3, +3, -2, +2, -1, -1, and so on. All of these points are listed over here. And the big idea with finding the inverse of a function is to swap all x and y values. So I'm going to create a new list over here, f inverse of x, and I'm going to get 6 more points. And all we are going to do is switch the x and y coordinates. So this will be 3, -3, 2, -2, and the rest like this. So now the only other thing that needs to happen is we need to plot these points on the graph over here. So we can start at -4, 5, which is way up here with ink. There we go. We can then go to -3, 3, which is right here. Then we go to -2, 1, which is right here. And -1, -1, that's that point. 2, -2 is right here. And 3, -3 is right here. Now, if you're confused as to how you should connect these dots, what you should remember is that anytime you find the inverse of a graph, it ends up giving you a reflection around this line, y equals x. I'll continue that here. So you can try connecting the dots any way that you can, but you want to make sure the graph looks like this. So when you look along this line, maybe tilt your head a little bit to the right so that this line looks like it's vertical. The blue graph and the red graph will look like mirror images of each other. That's how you know you have drawn the inverse of a graph correctly. Find the inverse of each function. There will be 2 examples here. F of x equals x over 5 plus 3. The first thing you want to do when you're trying to find the inverse of a function is simply replace the f of x with y. So that step is done, no math involved. The second step is you will want to swap the x and y. All right, so again, no more math. That looks like this. X equals y over 5 plus 3. The third step you want to do here is solve for y. This is where all the math happens, and this will usually be the longest step. So here we go. The first step I want to do here is subtract 3 from both sides, so -3, -3. That will give me an x minus 3 equals y over 5. And then the last thing I want to do here is get rid of this denominator. I want to multiply both sides by 5. So that leaves me with 5 times x minus 3 equals y. Now we're almost done. The funny thing is we started with f of x notation. We need to end with f of x notation, but we have a y. Well, y is just another way, or f of x is just another way to write y. But we've changed the function a little bit. So we need to use the F inverse notation to represent that this is the inverse of what we started with. So there's your inverse function. In this next example, we have that f of x equals the cube root of x minus 8. So again, the first step here is to substitute y in for f of x. Then we will want to swap the x and the y. So that will give you x equals the cube root of y minus 8. Now we can start solving for y. And the first thing we're going to want to do here is get that y accessible. We want it out of this cube root radical. It's trapped in there, we want to get it out. So the best, or the way to do that is to cube both sides. So now we will have x cubed equals y minus 8. And then the very last thing that needs to happen here is to add 8 to both sides. And you will end up seeing that y now equals x cubed plus 8. But again, there was this strange thing here where we swapped the x and the y values here. So this y isn't really y, and plus we need to write it in f of x notation anyway. So this will be f inverse of x equals x cubed plus 8. So there's your inverse function for the original. If an archer shoots an arrow straight upward with an initial velocity of 128 feet per second from a height of 6 feet, then its height above the ground in feet at the time t seconds is given by the function below. Here's the function. And we're going to use this function to answer 2 questions about this arrow. After how many seconds does the arrow reach its maximum height? And what is the maximum height of the arrow? These 2 questions seem to be awfully involved about asking things about the maximum height. And since we are looking to talk about a maximum, and if you think about this being a quadratic function opening down, that looks something like this. There should be a maximum value. That is just the vertex. So we're just trying to find the x and y coordinate of the vertex. So here's how we do that. We're going to have to know negative b over 2a, and normally this would be set equal to x. But all of the variables that are in the function are t. So we cannot use x here. In fact, it makes much more sense to use t here, because we can then immediately apply it to the second question. So here's t. We're looking for a time. So what that means is now we can substitute these numbers in for b. So this will be negative 128 over 2 times a is negative 16. And when you put that into a calculator, you should be getting back a positive 4 seconds. So this answer answers the question, after how many seconds does the arrow reach its maximum height? Good, we've got that. Now the second question is, what is the maximum height of the arrow? The maximum height of the arrow depends on how long it took to get there. Right? The height depends on the time. So the 4 will just get substituted in for the time here. So we can write something like this. The height at 4 seconds will give you negative 16 times 4 squared plus 128 times 4 plus 6. And at this point, you can just type all of this into a calculator and get 262 feet.